No Christmas test. That's what I wanted to speak to your class rep about, because I had a choice, you know, or we had it. I want to do one more lab test, and then I want to do an assignment. And I thought, will we do the lab test before Christmas or after Christmas? But technically, you're supposed to get 4 weeks notice, and I haven't given 4 weeks notice, but then I kind of have, because I've been saying we'll have a lab test. The other thing then as well is, I think if I set you the assignment to do over Christmas and then do the lab test straight back when we're in February, a number of you will spend a lot of time working on the assignment over Christmas, which is what I really hope you will do. And then after Christmas, you'll have all of that benefit, and the programming lab test should be trivially easy for you. But then I'm sure some people won't spend most of their Christmas doing the lab test or doing the assignment. Yeah, it's your fault. I know it's their fault. Yeah, so I don't know. That's what I'll chat to you about. We'll make a decision this evening.
What's the story with the Imagine Cup? So if then if you want to do something for that for your assignment, constantly
you forget about anything that I have to give you over the Christmas. Do the Imagine Cup. That's your assignment.
We obviously show you that we have been working through.
You actually have a deadline. The deadline for the Imagine Cup is the 31st of January. So you have to have your vertical slice. You have to have something developed and submitted, your idea and your implementation, by the 31st of January. So if you do that, then that's what you show me for your assignment.
And that can be a game.
Absolutely, yes. You can do the games competition. You can do the software competition, which is just an app or a piece of software that does something, or a web application or anything. It can be anything. But if you wanted to do an XNA game, absolutely, 100%.
No, it's just we were going to do software, but then we got one of them O'Reilly's books, and it's dead handy, so we were going to give that in the
Which your O'Reilly's book, the games one, is it? The XNA one?
XNA, it's just
and you like it?
Yeah.
Fantastic. Do that. Yeah.
So you've got a group of people working on the assignment. How would that work? For the Imagine Cup, how would that work for assignment?
Yeah, so the issue is that I need to find a way to evaluate what everyone's contribution on the team was. I definitely want to encourage people to do team projects and team assignments with the Imagine Cup and stuff, so that's not a problem. What I'm doing with the 4th years is I'm assisting anybody that's doing a team project has got to use a version control system. Do you think that's something you could figure out? I mean, I can give you a class on how to use GitHub, which allows you to share code, you need to learn this anyway before you graduate. So I can do a class on it and show you how to set up a team project in GitHub so that you can share code amongst all the members on your team. And then what I'll do is I'll evaluate how many people have got the most GitHub check-ins, because I can see who's doing what then. Does that sound reasonable?
Yeah.
I think I'll do that then, right? I'll give you a kind of a crash course in GitHub, maybe next class, right? And if you want to do a team project, that's the way to do it. It's something you should know anyway. It's something you can put on your CV that you use Git. You know what Git is? It's a version control system, and it's how teams of people manage software, because it allows like multiple people to edit the same file at the same time, and it merges the changes. And also, for example, you can roll back. You can say, oh, well, look, I'm after creating something and I've broken it, and I want to roll back to the version that I was working on 2 days ago. So you can do all that kind of stuff using a version control system. So, what's that?
We use the operating system.
Did you really?
Well, we only pulled the information through, like an Linux command.
Great. Oh yeah, well that's what we'll do. We'll do the command line Git things. We'll do it in the next class then, right? Is that alright with everybody? We'll have to have a chat, you and I. You're the class reps proxy for today. There's no point having a discussion with the whole class. We just need a one-on-one, chat. We'll make a call and we'll make a plan then, right? So you all saw Misty Bots last week? Okay, first of all, this is the solution to your to last week's lab. So what you absolutely need to know at this stage, right? Everybody needs to know about classes. You should write this down. Classes, encapsulation, fields, properties, methods. That's the number one thing that we learned in terms of OO. The second thing you need to know about is inheritance. Classes, encapsulation is basically the first thing, right? Which is basically classes, methods, fields, and properties. Constructors as well. So that's all related to the idea of a class. Is everybody okay with that? The second thing you need to know about is inheritance. And the thing with inheritance you need to understand about, well, I suppose actually one other thing which I forgot is public, private, and protected. You need to know what those 3 terms mean. You then need to know what inheritance is all about, the colon operator in C#, and you need to know about static and dynamic method binding. So whether you use virtual and override, or whether you leave them out, what's the difference between those two things? And then the third thing you need to understand is the polymorphism thing. So being able to create an instance of the base class, or being able to declare a type of the base class and instantiate it as any of the derived classes. That's called polymorphism. Right? It's the ability of an object to change its type at runtime. So there are the three kind of pillars of OO, which you should know by the end of this year and coming into the next semester. I'm going to assume that everybody knows all those things, and it's very second nature. So this little lab that we did last week tests you on every aspect of everything that we've done up until now, without the XNA stuff being in there. So in this one, I said we're going to make a base class called shape, and there's the base class called shape. And the base class called shape has got a center point. So this is an example of a has-a relationship. So what we're saying here is that a shape has a center point. So, it's just you make it a field of the shape class. Do you see that? And then you can make a property out of it as well. So private point center, and then this is an example of making a property out of that field. Is that all right with everybody? So that's a shape has a center point. It's not an is-a relationship. If it was an is-a relationship, we do colon point up at the shape there. Do you understand that? That's a different type of relationship. So that's a has-a relationship. And then
so is-a is inheritance, and has-a is just declarations.
Is declarations, exactly. Yeah, that's it, exactly. So this one we said that there's just basically a one way to create a shape, and this is the way to create a shape by passing in a point as a parameter. So you can't create a shape without giving it a center point. That's what you're basically saying there. Because there's no default constructor. Oh, sorry, there is a default constructor. Sorry, I made one. There you go. There's the shape default constructor, and I just instantiated a new point object. And then I made a virtual float area. This, by the way, is not the right way to do this. There's a better way to do this called an abstract class, which I'll show you today. So this is basically saying the virtual there indicates what? What does the virtual indicate there in the method signature? It means that we want to, in the case of a polymorphism thing here, we're going to use this, the one from the derived class rather than the one from the base class. So that's the shape base class, and the shape base class doesn't extend anything. But my circle class then extends shape, and that's the way you say circle extends shape, just by going colon shape. So that means everything in shape has a circle also has. But I've added a new field here called radius, and I've made a constructor here which takes the center point and the radius of the circle. And this colon base here, what does this mean?
Inheritance from the base class.
Yeah, well, when you do it in a constructor here, what does it mean? Colon base. Come on, you know this. Exactly, it's calling the constructor in the base class. That's what colon base means there. So when you go and instantiate a new circle, because a circle is a shape, this is basically saying call the shape base class constructor and passing this parameter in. So this is going to set the center point of the circle, and then the radius gets set in this constructor. So that's important as well. And then the override float area. Override float area there means that this is going to, in a sort of polymorphism example here, in a polymorphic case, it will use this rather than use the one from the base class. So I'm changing the behavior of the area method from the base class. And the override toString, I didn't put a toString into the base class, so where does it get that from?
That's the default one.
Yeah, so all classes in C# extend the base class of object. Alrighty. So, same thing with box. Box also extends shape, and it adds an extra property, which is the width property. And the same thing there, colon base center means call the base class constructor, and there is the area of the box. And then we also made a line, and I didn't indicate in the lab that line has to extend anything. You could have made it extend shape if you wanted to. But then you'd have to try and keep the center point, which would be not a big deal. The center point in the start and end, you just have to recalculate the center point every time you set the start and the end. And so there we go. And then I made these properties. So these are properties that don't correspond to any fields. Alright, so this is a calculated property. There's no field called slope, there's only a property, and it's calculated from the start and the end point. So just take n dot y minus start dot y, and the same with the intercept. So from the outside you can go line dot slope and line dot intercept, and they look like fields, but they're not fields, they're just calculated. So that's the idea with that, and you can never set these because I've only made a get. Does everybody understand that? So they're what they call read-only. They're read-only properties.
Last year you have like indicators and setters patch. You have like n equals values and all. What is value? Where is it coming from?
It gets it from the right value. When you go something like, I'll show you. Did we make something in the shape? So the shape has got a center. So over here in program, if you were to go shape s equals new shape, and then you go s dot center equals new point. Alright. See this bit here? This is the value. So this gets passed in as a parameter, if you like, to the center. And whatever's, this is called the OR value. So whatever's to the right hand side of the equals, that's what value is. Is everybody clear on that one? Everybody happy with that so far? Alrighty, so that's on the website now. You can download it, and if you're not clear about any points in there, you can just download that and you can run it in the debugger and stuff. Alrighty, let's do a little small change to this program, and this is to make what's called an abstract class instead. So we had this situation here in shape, right? That we've got a method there called area, and we're saying that it's not possible really. We don't want it to be possible to create a shape instance. We only want to be able to create subclasses of shape. Because how do you calculate the area of a shape? There's no way. Sure, there isn't. It has to be a square or a circle or something like that. Does everybody see that problem that we have? So there's a way around that in C#, and it's by making this abstract, right? And if you make this abstract, so you go abstract float, you can get rid of this here. And you just put the semicolon like that. And then if you make that abstract, that has the consequence of making the class an abstract class. Okay. So once you make something an abstract class, right, it means you can put methods in it that you don't have to have a body in. So when you make something an abstract class, that also has the consequence, and you can see that we get this error here. Cannot create an instance of abstract class circle shapes.shape. Alright? And that's because when something is abstract, it means that you can't create an instance of it. That's the rule for an abstract class. So an abstract class, number one, can have methods in it with no body, and number two, you can't create an instance of it. So what's the point of an abstract class if you can't create an instance of it?
It's supposed to be like a base class.
Exactly. It's just a base class that other things can extend, but you can't create an instance of an abstract class in itself, right? So that then doesn't work anymore. Shape S equals new shape. You can't do it anymore because you can't create an instance of an abstract class. What would happen in a subclass of an abstract class? We'll say like box. What would happen if I didn't override the area in box? What would that imply about box? If I didn't put that method here, if I didn't override the area from the base class, the abstract method from the base class, what would that imply? It would imply box has no area. Okay, that's semantically, but just in terms of programming, what would it imply about box?
If I didn't. To find the area.
Yeah, it won't have a method to find the area. So the base class is abstract. If the abstract class doesn't override the methods from the base class, what does that mean about this class, the derived class? Any ideas? Huh? It doesn't exist. Yeah, it does exist, but it's also abstract. Okay, so you don't have to extend you don't have to put this in here, but if you don't put it in there, it means you can't instantiate a box because a box is also abstract. Do you understand? If you have an abstract method in a base class, you don't extend that into the derived class. It means the derived class is also abstract and you can't instantiate it as well. I'll show you that. Look, if I get rid of this. Public override float area. Okay, maybe it's different in C#. It doesn't seem to let me. Does not implement the abstract member. Okay, it's different in C#. In C++, it would let you. It would let you do that, but it would mean that the derived class is also abstract. But in C#, when something is declared as a subclass of an abstract class, you have to put in the override and you have to implement the methods. Is that alright? Everybody happy with that? Did everybody know what an abstract class is? Anyone any questions? I see a lot of confused faces out there. It's really simple. But you just need to let me know if you get it or not.
Yeah, we say, one shot one more time.
Sure thing. So, okay, so the principle behind an abstract class is this. Sometimes you want to make a class, and in our example here, shape, right? With certain methods that things have to override. Alright? And this is an example of one of them, okay? In the base class here we have area, and it doesn't make sense that a shape has an area. It's only the subclasses of shape that has areas, right? So what you do is you put the word abstract here in the method signature in the base class. Alright? And you also have to put the word abstract up here, public abstract class shape, alright? And that makes the class an abstract class. What this implies is that we can no longer create instances of the shape class. That's rule number 1, when you use those two things together. Rule number 2 then is any class that extends shape has to have an area method in it. That's the second rule. That's it.
Okay.
Alright? But it just, I mean, it avoids that situation of having to put like a dummy method in there. You know, that it looks like it's just going to say, I'm not implemented or something like that. In this case, you know, you just put semicolon there and it means you don't have to put a method body in.
So basically, say you had a circle, square, and rectangle. They have to have an area.
Exactly.
But they all have different ways to get that area. So they all have
Exactly.
different methods.
Yeah, they all have different methods. But what it's saying now is that everything which is a shape has an area.
Yeah.
Because all the subclasses have an area method in there, and they're all going to have a different one. Otherwise, you can't create them. So there's box colon shape, and then you go override float area, and then you put the implementation in there like that. And just the only other implementation is you can no longer now go something like shape s equals new shape. That's going to give you a compiler error. And it will give you a compiler error to say you can't create a shape because it's an abstract class. You can't create an instruct of an object. You can only create instances of things like boxes. And that's okay. Alrighty, is that okay with everybody then? Everyone happy with the idea of an abstract class? Should we do some XNA programming then? Because this week's lab is XNA stuff, right? So, do you want me to go through the kind of fundamental concepts again, or should we kind of do a little bit of the game maths, the vector stuff?
Let's make pictures.
Okay, right, let's make pictures, right? Do you want to have a look at Misty Bots again?
Yes. Yes. Yes.
Okay, we'll do the one player, play against the computer, so I can use the mouse.
That's not Misty Bats, that's Pong.
Excuse me, this is a 100% original game of my own design. This is called Misty Bats.
An arguing failed.
Copyright.
Is there any way to actually beat the AI?
Yeah, because it doesn't move at the same speed as the ball. So you know you just need to fire it fast at it. You can beat the AI. Yeah. Okay, so we'll do some simple kind of drawing stuff then. Yeah. All right. So just going to create a new Windows game project here. Okay. Can anyone tell me the methods that game 1 gets from game? There's about 4 or 5 of them. 4 of them.
Update, draw.
Okay, so they're the 2 important ones, update and draw. And what other ones?
Load content.
Load content and,
Unload.
yeah, unload content, which you don't really have to do anything with. And the other one is initialize. So when is initialized called?
Beginning one.
At the very start, and it's called once. Load content, The same, at the very start, right after initialize, load content is called. Update.
Every time anything's put in, like mouse movement, or anytime I'm going to draw a new sprite.
Exactly.
Draw, yeah.
So it's, well, update is called once per frame, okay? And then draw gets called once per frame. So you update your scene and then you redraw it. So what would happen if I did a really long running operation in update?
Take all the frames out, so
Exactly, your game would hang. So you try and be as efficient as possible. No big while loops or things like that in there. You know, okay, well, just to make sure everybody's clear on that concept, so I want to now draw a sprite. What's the class that represents a sprite in XNA? Texture 2D, okay. And what's the class we use to represent positions? A vector 2. Okay, there is one weird thing about the vector 2. And I put a link on this about this topic on the website. It's a bit for you to read from Rob Moyle's yellow book. A vector 2 is not actually a class. A vector 2 in C# is a struct, like a C struct. Okay, so you can have structs and classes in C#, but there's a lot of differences between them. This only becomes of relevance when you want to make properties for this. And the whole point here is that you can't make a setter property for a vector 2, because a vector 2 is what's called a value type. Now, I'm not going to explain this, right? I'm going to put up a little document for you to read which explains the difference between value types and reference types. Okay, but basically it's not quite the same thing as a class, and as a consequence you can't make a setter for it. That's all you need to know about it. So typically, for things like sprites and things like that, you might make them private and you might make properties for them. For the vector 2, you have to make that public. That's the only thing you need to remember about it, right? But anyway, I'm just going to do a vector 2 for position. Just for the crack, let's make a sound effect as well. Now, a lot of this stuff, you know, you just figure out by looking at examples or by doing Google searches for how you do something, whatever. Okay, so let me make a sound effect. That is a class, right? So, where am I going to put the code to load the sprite and the sound effect? Into load content. That's what load content is for. So you load the content by means of the content pipeline. So you go sprite.
To create them methods, or did they just come preloaded when you?
They're part of the framework, and the framework calls these for you. So you don't actually call these. Sometimes you have to call load content on your own objects, right? But in your game class, it gets called for you by the framework. Alright, so you just put the implementation of those in your code. So to load something from the content pipeline, you go sprite equals content dot load. Those two angle brackets, what do they mean?
Yeah, how do you put your texture to the inside?
Yeah, what is it? What is a texture 2D? It's a type. In C#, one of the things we'll do in the second semester is making use of a type as a parameter. So you could make something like an add method, and it could take integers, strings, floats, or whatever, and you actually pass the type as a parameter. That's called templates in programming. And this is an example of making use of a template class. So we're using the texture 2D version, and you don't really need to know too much about that for now, but just that's how you load a texture. So, oh yeah, I have to add some content to my project. So let me add a couple of content items. So let me add existing items here. OOP, I'll find. Let me do a different one. Let me find my game engines course. There's my little tank class, and there's a bullet class. Let me add both of those guys. And then let me also, you notice by the way, this is very important. When you're doing your lab tomorrow, I get you to make your first XNA project. When you're adding content to your project, you don't add it to the main project, you add it to the content part down here. So you have a solution with two projects in it. The one project is all your code, and then down here is all your content. So make sure when you're adding, you add it to here. So we go add existing item, and I'll add a little sound effect. Is there any sound effects there? No. So I'll go find a sound effect. Okay, so there's bar, and then there's two pieces of content. So let's add the small tank. The other thing to say is when you're loading content, you don't put the .bmp or the .png extension. You just type the name of the file that you want to load like that. And then let's just draw it. Okay, so this is something you've got to put into the draw method here. Sprite batch dot begin and sprite batch dot end, and you put your drawing code in between there. So to draw a sprite, it's sprite batch dot draw. And then you pass in the parameters here for drawing. So I want to draw that sprite that I previously created. The second parameter is, and you'll notice that there's loads of overloaded versions of this one, right? The one we're going to use today is the vector2 position. So I'm going to put in, I need to like declare a vector for position. Pause. That'll do fine. Oops. Then the last parameter is called the tint. Color.white. Okay, so that's going to draw the sprite there. And I need to set pause to be some value. And then I also want to get it moving, so I need to put some code into the update method for that. So there's pause. So in my initialize method, I'm going to give that an initial value. Pause equals new vector2. Just giving it the position 100, 100. Now down here in my update method, I want to put some code to move it, okay? So this time I'm going to use the gamepad, but you can use the keyboard or whatever. And the code is almost very similar to use whatever one. So the first thing is, right, for input in XNA, you get state objects, all right? So, for example, I'm going to delete that code there. If you want to look at the gamepad and find out what keys are pressed, you know, what buttons are down, and the state of all of these thumbsticks, you get the gamepad state object, and you use that object to query the gamepad state. So gamepad gamepad state.
And that's the one just for the controller? That's
Yeah.
the keyboard as well?
Yeah, I'll show you the keyboard one. You go gamepad dot get state. Here's an interesting thing here. I'm sure you've noticed this, okay? Oh yeah, this actually takes gamepad dot. Now what's the? You have to tell it which one you want to get the gamepad state from. Let me just, because you can have up to 4 controllers. So let me just Control Z to get back to the code that was there beforehand. I can remember how you do that. Yeah, player index dot 1, right? And you do 1, 2, 3, 4 to get all the various different control things. So I just want to show you something. I presume you've all realized this, right? But just to make sure, gamepad.getState. That's an example of a particular type of method, isn't it? What kind of method is it?
The computer is constantly checking to see if the button is pressed down, so it can do that, whatever.
Absolutely. Now, don't forget, this is just get called once. It will check that if it's pressed, it comes back, and then it's going to execute that method over and over again. Specifically, gamepad.getState. Where's the object that the method is getting called on? When you go something dot something, it calls a method on an instance, doesn't it? So there's no instance there, so that means that method is what? Somebody say it? It's not abstract. That's not what abstract means. What? Static. It's static method. There's an example of a static method on the gamepad. There's no gamepad object created at that stage, so it's a static method. You know, if you looked at the signature for that, you'll see that it doesn't really, you know, tell you much from that. But if you look it up, if you actually looked at the source code for that, you see that that's a static method. It's a method that you don't have to have an instance of a class created on in order to call. Okay, so then that gives you the state, and then you can do various things with the state. So you can go if GP dot, and you see that there's loads of stuff here: buttons, D-pad, connector, thumbsticks, and the thumbsticks give you values between 0 and 1 on the x-axis and 0 and 1 on the y-axis. Let me just do the D-pad, because the D-pad is really easy, right? Gpad.dpad dot, and then this tells you whether up, down, left, or right is pressed. So let me do up. Now, is that a Boolean? No.
We need to wrap it like is pressed. Yeah, it is pressed or is down.
Is key down or something?
So
No.
get GP state is key.
Whether the up, yeah, what is it then? Can I see? Oh, it's called an input button state to bool. Okay. Oh, there you go. Button state dot pressed. All right, and there's another example of a static, right? Button state dot pressed. So that tells you if the up key is pressed. So what do I want to do if the up key is pressed? I want to go up. All right. So here's a quick question for you, right? I have a vector here called pos. This is where I'm drawing it. How would I make it look like it goes up? What's that? I change the position. Which bit of the position do I change? The Y. The Y. So it's the Y you change. And then that leads us to an interesting question: is where's the origin? Huh? In XNA and in all graphics, the origin is in the top left. Now you might have, when you do coordinate geometry, you're used to the origins being in the bottom right. But in graphics, it's in the top left-hand corner. So if I specify 100 and 100, and I want this thing to move upwards, what do I do to the Y?
Decrement the y-axis.
I decrement the Y. Exactly. So I take something off the Y. The next question is, how much do I take off the Y?
Depends on your grade. Depends how big your field and how fast it goes.
Exactly. So it depends on how fast you want it to move. The more you subtract from the Y, the faster it will move. In the real world, what's the thing that determines how far something moves? It's not just the speed, but it's also... Huh? No, in the real world, if I have something that's traveling at 3 meters per second, so the speed is one thing, and the next thing is the...
Distance.
How do I figure out the distance, given that something is traveling at 3 meters per second? How far has it traveled? It depends on...
How time?
Depends on the time, doesn't it? So you have to know the time, and you have to know the speed, and that's how you determine how far something has traveled. Isn't that fair enough? Something is traveling at 3 meters per second, and it travels for 2 seconds. It travels 6 meters. Everybody understand that? So we need to consider how long has elapsed, right? So we can say that the speed, we can say, I want this to move 100 pixels per second, all right? Or you can even say, well, we'll give it 50 pixels per second, right? And then what we need to do is figure out how much time has elapsed. And this is how you do that in XNA.
So Brian, remember when you say you wanted to move 50 pixels per second?
Yeah.
I assume that the amount of space that's on the screen is the current resolution of
It
the
is,
laptop,
yeah.
or the screen, whatever.
Yeah, so when you tell this thing to draw, it uses the resolution, which I think is 800 by 600, but you can set it. I have it in my other project as to how to set the screen resolution. I don't have the code just here, okay?
Can you get it to update
Graphics
itself,
referred-
or do you actually have to specifically put in? You have to hard code in the resolution, or can you
Yeah.
get it to call the resolution from the system?
No, what you can do is you tell it what resolution. Of course, you can query the system to see what's the native resolution of the screen. Yeah, definitely. But what I tend to do is I tend to maybe say draw it 1024 by 768 and go full screen, which you can do as well. But then you're using a fixed resolution. But yeah, you can tell it, because this is going to run in a window, for example, and there's a Boolean value called is full screen that you set to be true. So there's my speed. What's wrong with that? Oh yeah, time delta. This is how you get how much time has elapsed since this method was previously called. You get a game time parameter, which is passed in, and this actually gives you loads of information, but you want elapsed game time dot total seconds. And that tells you how many seconds. Now, is that a method? No. Oh, it is a method, I think. No, it's not a method. Oh yeah, I know the problem here. The problem here is that's a double and you need to cast it to be a float. So that tells you, for example, if you're running at, we'll say, 20 frames a second, what's the time delta going to be? Yeah, what's it going to be? If you're running at 20 frames per second, how many seconds will have elapsed? Okay, if you're running at 1 frame per second, how many seconds elapses between each frame? 1. If you're running at 2 frames per second, how much time elapses between each frame? Half a second. Alright? So if you're running at 20 frames per second, it's 1 over 20. So does everybody understand where this number is going to come from? This is how much time has elapsed since the method was last called. And that determines by how far you're going to jump forward. Now if you're running on a very slow computer, you might only get 10 frames per second. Or if you're running on a really fast computer, you might get 1,000 frames per second. But you want your game to look the same regardless of whether it's a slow computer or a fast computer, which is why you have to take, the time delta into consideration. So anyway, there's the time delta and there's my speed. So the little equation which you all implicitly know is to calculate the distance, and I'm going to call that delta x, so the change in position is equals to your speed multiplied by the time. Isn't that right? So by how far you move, if you're traveling at 3 meters per second for 2 seconds, you go 6 meters. So that's this equation here. Delta x equals the speed times delta t. That makes sense? Everybody agree? So we'll write that equation here for the y, You can basically go pos dot y is equals to pos dot y plus the speed multiplied by the time delta. Or in our case, we want it to be minus the speed, because I want it to go in this direction. Now, in the next class, we look at how you make a vector to represent the direction in which you want it to move instead, alright? So there we go. That's if the up key is pressed, that's going to happen. And if the down key is pressed, I want it to go in the opposite direction. And then if the left and right keys are pressed, what do we want to do? I want to do something with the x.
Could you explain why it's speed times time delta again?
Absolutely. If a car is traveling at 6 meters per second, for 2 seconds it has traveled how far? 6 by 2 is 12. So it's by how long you want it to go for, and then the speed at which you're traveling. So that's what you're doing. So you multiply one by the other to find out the distance traveled. Does that make sense? You sure?
And you were saying about the amount of time since it was called that.
Sure.
And,
Yeah, the time delta. Right. So what I'm getting at here with time delta is if you're updating this game 2 frames per second, time delta is going to be a half. Because it's saying a half a second since the last time this method was called. Alright, so that's where time delta comes from. It's how much time has elapsed since the last time we updated the game.
So if it's called, the longer it's called, the more it'll...
Exactly, yeah. So if you've got a really slow computer and you're updating, we'll say, 2 frames per second, then you're going to find that this method is going to get called very infrequently, but with a big time delta. And that's how you factor in, you don't want, for example, to test your game on a slow computer, then you go and move it to the iPad, and suddenly you find that everything is just moving at different speeds. So you have to take into consideration how fast the computer is running. Anyway, that's it. Let's hit F5. Hopefully it will run.
You didn't fix the tournament,
Possibly.
the right arrow was on the right one. You didn't change it at all.
So there's the x equals x minus, and then if I press the right key, I want to go x equals x plus the speed
You
multiplied by the time
have
delta.
down there twice as well.
What's that?
You have down done twice.
Yeah, so the next one should be, the y one should be minus, that should be, sorry, up. Oh, maybe I've got two the same. Let me get rid of one then.
Down back.
So there's up and down, left and right. So that's everything there. And just as I get rid of that cornflower blue background, I'm going to change that to be white. Wow. Look at that. That's practically a whole game. That's practically Call of Duty. Black Ops.
I think it's a bit better than Black Ops.
I think it is, isn't it? Okay, so yeah, in the next class we'll talk about vectors in a little bit more detail. Now the only thing is, like, I just warning everybody that in order to do any kind of thing with games at all, you need a little minimal of maths. And the maths you need is very, very simple stuff that I'm sure you all did in primary school, let alone secondary school, which is trigonometry, and another thing then called linear algebra, which is addition and subtraction. And I'm sure you've all done that in primary school. So I don't want anyone complaining that there's too much maths on this course. I personally did not do honours maths for the leaving cert. I did ordinary level maths, and I find this stuff really, really easy. So no complaining about the level of maths. And nobody's saying I was never good at maths. I can't do maths. That's not acceptable. You have to know a little bit. Just a little bit. But sorry, there is one last thing. Say I wanted to take that and I wanted to put it into a class. So I wanted to make a class to represent the bat. Does that seem like a logical thing to do? When you're looking at the game, you're thinking, I've got an object on the screen which is a bat, and another object which is a bat. They could be just two instances of the same class. And then I have a ball. So if you wanted to do that, how would you get access to stuff like the content and the sprite batch from another class?
Inherit the game.
That's not good. Definitely not inherit from the game, because there's only one instance, you know. So if you're inheriting from it, you're saying you got multiple games. How would I get access to the sprite batch and the content from a different class? There's loads of ways to do it.
The colon,
Yeah, that's inherit from. What you're saying is that the that's not going to work. And just to be clear, why that is not going to work? That's not going to work because basically then you're saying that everything is a game, and it's not.
And just call the method.
Call what method?
Make the method.
I'll give you an example, right? Say, for example, I wanted to make a class here called bat, which is what I'm getting you to do in the lab.
Is there any way to make it so that the update method actually calls the sprite instead?
Alright, so I've got a bat class in here.
Well, if you just inherited it from draw.
Add new item, C# class called bat, right? We'll say in this bat class here, basically, I wanted to have a draw method in here. Alright, I'm just keeping this very simple now. Void draw. Okay, I want the bat to draw itself. How does it get access to the content from the other class?
Make the other one public.
Yeah, but if it's public, that's, you know, fair enough. That's one thing you've got to do. It is public. First of all, you can't do that with everything because the sprite batch is okay, but the content it gets from the... How do I get access to it from there? Huh? Yeah, but how do you get access to the instance?
Inherit from draw.
What's that?
Inherit from draw.
Inherit from draw in what though? In this, make this a subclass of game as well.
No, not game, but just have draw in game, which draws on the sprite back.
Okay, you can only inherit from classes, you can't inherit from a method.
I thought draw was.
Come on, there's two obvious ways. Well, okay, here's way number one. I'm really disgusted that nobody has spotted this, because that means you kind of don't really understand what classes are. Just make a field. You know, public, void, content, or public, you know, content. We'll say it like that. And then you just need to figure out what's the type of the content. Content is a content manager, game.content. Oh, sorry, not in there. In the actual class itself, like this. What is the type of it? Content content manager.
You're not using the XNA framework.
Yeah, it is definitely. And then you should get a, like this. And then you just click using that. So that will get rid of that. Okay, so now a bat has an access to the content, and you simply write accessors for it, and when you create the bat, you just go bat.content equals content. Does that make sense? Watch this. Now look, watch. Bat equals new bat. Bat.content equals content. Alright, does that make sense? Why does that work? Because what is the content? Content is a reference, so it's okay. You're now just saying that these are the same thing. They're just pointing at the same object. So now the bat has a reference to the content object. Does that make sense? That should make sense, right? And if it doesn't make sense, go back and look at last week's lab and how you basically set properties on objects, right? Does that make sense?
So basically, what you're doing there is you're setting a bat class aside, and you can call multiple bats using the same content and display it, is it?
Well, in this I'm just making an instance of another class, and I'm just setting a value on the class, that's all. You know? So this is just a field in the bat class, and I'm just saying the field in the bat class is the content. So now bat can use content. Do you understand? Yeah.
So if you were to make like new bat2, you could just go new bat2.content equals
Exactly.
content and just keep
Yeah,
it.
perfect. Perfect. Another way to do it, which I quite like, is to make this thing, which is called a singleton. But maybe we don't have time for that. I'll just show you very quickly. I quite like doing things like this. So what does this mean, right? Static means what?
You don't always
You don't have to have an instance of the class to create it, right? Game one is what? It's the type. Alright, so now there's a variable, which is a field here, a static field called instance. In the constructor for this, you can go instance equals this, which means when the thing is constructed, you're setting the static instance member to be the object, because there's only ever one game, one object. And then over here, you can just do this. Okay, and then you get access to the content and to the sprite batch and everything via the instance. Alrighty, that's called a singleton in programming. It means there's only ever one created, because the static is shared amongst all instances. Because only one instance is ever created, you now have the static instance, and then you can just get access to that from all the other classes. So now you can get access to the game from everywhere. Does that make sense? Alrighty, let's leave it at that then for today, okay?
Sorry, Brian.
Yeah. Let me just stop this thing first. Yeah.